Yeah, so those who wants to know the answers, I believe first page is very easy one, right? There is no problem. Somebody wants to know any answer for any question for the first page? No?
So actually, that 10 1 volt 50 hertz kilohertz that explanation.
10x.
No, that
Question number 6. 2 volt 50 kilohertz. Okay, 50 ohm. We already done this in the lab. So if it is 50 ohm, it's half,
okay.
right? Half voltage. So it goes something like this. You want to see 2 volt 50 kilohertz or any frequency, you are going to see 1 volt 50 kilohertz. The frequency won't change. This is inside the function generator. If you are choosing 50 ohm, yeah. Hmm? I'm not audible. Can you get the mic from inside? If I am not audible, please come nearby. Right? Right? Those who cannot hear me, you can come here. Nakul and other people, Vaishali, Swarna, right? Hmm? It's on. It's on. Yeah. For second page, sometimes this is an interview question. BJT. Battery. Battery नहीं. Okay. So BJT is a which kind of amplifier? What do you think? CCCS. Okay. CCCS because the fact that why do you say triple CS? What is the fact behind that? Or you know the answer already? Okay. So if you're looking at the BJT input impedance, it's finite. Input impedance of BJT is low and output impedance of BJT is high. So input impedance of BJT is low and output impedance of BJT is high. This is only happening in current control current source. Those who were with me in my laboratory, they must have written this, right? The combination of input impedance and output impedance. So you need to look at that. 10x probe, yeah, we want to have it voltage control voltage source, right? Okay, the current probe will have low. Okay, inductor acts as circuit,
So short and open.
so B. Capacitor,
A.
okay. Then CCCS, what do you think about it?
0 infinity. 0 infinity.
Okay, I need to.
Sir, capacitor. C over. Sir, capacitor. DC blocker.
No, I'm writing whatever you are saying. Okay, I haven't checked that. Okay, so you are saying wrong thing. So capacitor exhibits low or high? High impedance. So that okay. So triple C. Okay, thank you. So now 14.
0 infinity.
0 and infinite. So which one?
A.
A. VCCS infinite infinite.
0
0 0. What about now 18, 19 and 20? 18 and 19. Huh? Which one? The first question. 8. ABC. ABC. Okay, so you are writing all correct answer. That is the way you are going. Uh,
I'm thinking A. Sir, if A is correct, it includes BC.
yeah, but I wanted to write down that you are going to see only these many frequency components or these many. So the first one will be the correct one because it will have all the components, right? All the harmonics of 1 kilohertz. Maybe I formed the question wrongly. Yeah, but you are going to see only these components. Like in this case, there is no 1 kilo, 3 kilo, 4 kilo are not there. So it's a wrong answer.
So no, but like the first, third, and sixth harmonic will be one.
Yeah, so you are going to see this also, but you need to see other things also. Right? If you are doing ABC, then it's fine.
Yeah, ABC.
Okay, fine. Main purpose of this surprise quiz is not just getting marks and all these things. It's for learning something. So you learn it, then it's fine. So if a sinusoidal wave of 1 kilo, so what do you think?
C.
So first fundamental, second and fourth harmonic. So C, right? And the Lissajous pattern is measured XY mode. Okay, fine, right? So all good, all fine. Now we can go to the place where we were. Okay, there is no double click. Okay, so do you have one semi-log paper with all of you? Okay. If you need some more, I got some more also. Where is Vivek? Can you distribute them? Because some people who are new to our class, they don't have any paper, right? So, yes. So this is what we will need to draw today. Right now, it's not part of Bode plot. We are learning Bode plot. There is a place where we are going to learn driving point function. There we are going to learn input and output impedance. Meet me after the class. I'll derive for you. Okay. But this will disturb the flow of the course, right? Okay. So this is what we need to draw. So when this question is asked to you, you need to find out following things like what is the order of the system, by the way? 2. What is the type of the system? No, 0. Number of integrator, each 1 by s, that is going to give you one integration. So there is nothing like that, but there is a derivative, right? Okay, now you need to write down number of poles, number of zeros, and the location, and the gain k, right? So now can you tell me the poles, Akshita? So where are the poles of this transfer function? -1 and -3. Very good. Now zeros, somebody can volunteer. Vaishali. So where are the zeros? And 0. So this is also one of the zero frequency, right? Now what about the small signal gain k? Okay, so 1.5 divided by 3, that is going to give you 0.5, right? So now can you draw this magnitude plot using semi-log paper? So today I'm not going to draw it here, but meanwhile just look at that what I'm doing. There is something called MATLAB. So those who just have heard about MATLAB, everybody know about MATLAB? You have MATLAB in your laptop? Okay, then the next assignment says that the question number 2, that you have to make 5 different Bode plots using MATLAB. So take like the printout of that, and next time when you are submitting the assignment, you can staple it with the assignment exam and give it to us, right? That is what you need to do. Yeah, so assignment 1, you are going to do it here. All the things which you need to do it on Bode plot. So I'm going to give only one Bode plot, only one example. So you will do it, and like you will be expert, and thereafter we are not going to look at Bode plot ever, right? Then I believe that you are expert, right? So this is very easy. That is not complicated thing. First of all, if you want to write down, so is it visible? Okay. So TF stands for transfer function. If you want to operate everything in Laplace, like Laplace operator, then this Laplace operator has to be defined like this: s is equal to transfer function of something s. So this is the way you need to write down. So I'm defining that this is a Laplace operator. If I want to define it at like Z. Have you heard about Z? It's called discrete, like Z transform. Have you studied Z transform? Yeah. So if you want to write down transfer function in discrete domain, then you have to write down Z equal to TF. Then you can write down same thing, right? Then your transfer function has to be in discrete domain, in Z domain. It should not be in Laplace. But right now we are learning only in continuous time. Then we need to make things in continuous time, which is the first one. So I am writing in terms of first one. So it's very easy, right? So right now I am going to write something in Laplace form. Now I am writing one transfer function. So transfer function will have two things. One is numerator and denominator. So in numerator, as this is matrix laboratory, or how to call MATLAB is matrix laboratory, right? Yeah, yeah. So I'm writing this. So what was the transfer function? 0 and s square plus, on numerator it's s square plus 1. So right, and yeah, so it's s square plus s. Okay, so it's 1 1 1 1 is 1 1 0, right? No, I cannot do. It's not in my hand. थोड़ा बढ़ा के लिए आ गया जो. Right? Yeah. So 1.5, right? And denominator. So I am writing all the polynomials. So first one is s square and then s raised to 0 and so on, right? That is how. Yeah. So you can keep 0. All are same. If you, okay, now tell me 1, 4, and 3. So is it correct? The transfer function created by MATLAB. It's very simple. Just you have to write the polynomials on numerator side and the denominator side. Right? Is it visible? Yeah. So now the screen is down only, right? So this is already available. Yeah, so you have to tell at the beginning itself your transfer function will be in Laplace domain or in Z domain. That is what I defined already, right? So now I want to draw Bode plot. Bode plot is combination of phase and magnitude, magnitude both. It's not only about magnitude. So when you are going to write the Bode of H, you are going to have two things. It will be magnitude as well as phase. So let's draw it, and when you are doing this, let's make the grid on. When you are making grid on, you will have, you can see the grid actually, right? So it's very simple to do that. There are 5 questions are given to you. You have to make it using this command line. One question is using command line, and one is called Simulink. Have you heard about Simulink? So hmm? Only heard. So now you have to do it one assignment, so you will be expert, right? There is no other choice, right? So this is easy, right? You can make all the Bode plots. This Bode plot you need to draw right now, and the Simulink is the one. Let me check where is it, because I also have not. Thank you. Generally, I am not in favor of Simulink. Uh, it's it's very easy actually, and there is no innovativeness, I should say. So because everything is ready made, just you have to plug and play. There are some kind of block diagrams, and there will be some functions like transfer function, right? TFCN. You have to keep it there. You have to write down numerator and denominator, right? I don't know, maybe because of poor internet or. So generally, what we are doing in Simulink, Simulink will have the window, and there is a library. When you open the library, there are uh, some ready-made libraries like transfer function. It is known as TFCN. And when you double click this, it will open up new window where it will ask where you want to keep the poles, zeros, and small signal gain. Just you keep that, transfer function is ready. Right? It's GUI version of what we are doing in MATLAB. And thereafter, so something like this. Yeah. So it's open after. So I wrote something yesterday night. So like this, you can write down. Right? Numerator and denominator has been given here. Right? When you are going to write it down, you can give some input like from function generator, and you can see the output. And I am keeping two oscilloscope here. You see, when I run the simulation, I can see something here. Right? So I request all of you to just do some analysis and explore the things. Right? I am in favor of actually command command line of MATLAB. This is the way generally people write. All the people. I'm just teaching you so that it will be useful for you in control course. All control people are doing Simulink, right? So control is based on Simulink generally. We'll parallelly we will do that also, so that you can become expert of both. So is it doable? Like there are only 5 questions in your assignment. So question number 1 says, so question number 1 has 5 questions, and it says that you need to draw the Bode plot, right? Question number 2 says same Bode plot, draw using MATLAB command line. And question number 3 says that draw same using MATLAB Simulink, right? So these two you need to get the printout and you have to submit here. Out of these 5, I choose any one of them and I'll give you something like 50 minutes for exam. Same question. Out of these 5, I'll give you one question. So this Tuesday you have that exam and you have to submit that to my TAs, and then we will evaluate you. Huh? You can do it in your notebook. I don't care about it. These I don't care, because I am going to make the exam for that. Because generally what I experience, most of the people are copying from each other. So here I cannot do anything that like you are taking the printout here, right? So the best thing is you do it at your hostel, and then the first part I'm going to take exam for any one of the questions, or maybe I'll give some questions to some people, some question to other people, like in rotation, right? So 5 different copies of the
What do we have to submit?
prints, MATLAB ke prints.
Qualify with that use.
Yes, using MATLAB and using Simulink. Right? You will have different plots. Like their environment will be different, but answer will be same for sure. This is just for your practice.
Suppose Simulink will have to give that.
Yeah, you have to look at in oscilloscope or maybe some XY mode. There are lots of things are available. Even online videos are also available. So I'm not going into that. But if you are getting any difficulty, you can contact me or you can contact my TAs. Right? So you know how to do it in command line. That's very easy. Simulink is also very easy. You need to make one box which is TFCN. 2 sides, you have to give one input and one output. That's it. Right? Okay. So but before going to that, let's complete the phase margin. I haven't taught that, right? So I told you one thing, that designing key points are the system should have the phase margin more than 45 degree, preferably 60 degree will help you to get the stable system, because you are interested in no fluctuations at the output. So like you must have seen this kind of circuit. Have you seen it?
Yes.
So if I am applying here square wave, what will be the output? So if you are solving any operational amplifier, you are going to follow two rules. One rule says that, what is that rule? V plus equal to V minus, and no current flows inside, right? Or outside. So sorry, going inside, right? These are the two things you need to remember. And this will work only with the case that the gain of the amplifier is infinity. If it is not, then we'll study that also afterwards. So what you are going to get here, by the way, same, right? The use of this one is, this is an analog buffer. This is a buffer so that you can drive the next part. So the output should be same, but you are not going to see same, but you are going to see something like this, because it's passing through the transfer function of this amplifier. It might be first order. If it is like this, you are going to see this kind of response. If it is second order, you are going to see something like this, because as order is increasing, you will have oscillations, right? Yeah, noise, right? We don't want to see these oscillations. That's why I'm saying that you need to design a system with phase margin greater than 45 degree. Now till now I have not defined what is phase margin, first of all, right? But just remember right now so that I can tell you how to design it. Okay, so there is a magnitude response is given to you for this system. You know that after the frequency A, you are going to have such kind of response, means minus 20 dB per decade. Do you agree with this? Right? Or minus 6 dB per octave. Now the question is, what about the phase? Can you tell me, somebody, if I am going to write this in a phase, what will be the equation? Your 11th or 12th standard complex number. Yes, Akshita, you were saying something. So this is in j omega is equal to 1 by j omega plus a, right? So minus 10 inverse omega by a, right? All good. Okay, so now my interest is in three things. What is happening at omega equal to omega is equal to 0, what is happening at omega is equal to infinity, and what is happening omega is equal to a for the phase. So what is happening at 0 degree, sorry, 0 radian per second? Phase equal to 0. What about infinity? Pi by 2, minus pi by 2. Thank you. And what about a? Minus pi by 4, or the 45 degree, right? Minus 45, minus 90, and 0. So if I am going to draw the phase plot on the same axis, just at 0 frequency or very low frequency, your phase will be 0 degree. At very high frequency, it's minus 90 degree. At omega equal to a, it's minus 45 degree. And when you are going to draw it, it will look like this one. Are you following this? Is it like too fast for you, or you understand, right? So can you tell me, if this is the transfer function, how this phase plot will look like? Just I change to double pole, right? So what is going to happen? This will be changed to minus 40 first of all. What next in phase? So what phase equation we are going to have? Can I write twice? Can I write twice? You must be knowing the complex number. This is the same thing, right? I can write twice. So minus 2 times tan inverse omega by A. So everything will be doubled. Right? Now you may have different question where I am not drawing this thing, but I am drawing and I am going to define the phase margin. You know what is phase? Phase just now we have defined. So this is 20 log K and this is some frequency. Let's say this frequency is known as gain crossover frequency or unity gain bandwidth. Both are same. Or and this frequency is known as center frequency. Some people call it 3 dB center frequency, right? Or sometimes they call it 3 dB bandwidth. All are synonyms. And this is like this is also known as this is also known as unity gain bandwidth, because right. So this is with respect to omega. Now when I'm drawing the phase plot, you can draw it here also if you like. I'm going to write from, let's say for this one, I know that if it is one pole, just remember in your mind, like we understood that one pole is minus 20 dB per decade. One pole at 0 frequency is 0 degree phase contribution. At infinity it's minus 90, and exactly at the center frequency it's minus 45. But instead of that, if there are two poles at the same frequency, the 0 frequency will contribute 0 degree phase. At infinity it's minus 180 degree, and at the middle, which is the center frequency, you are going to have minus 90 degree. And you can increase the number of poles and zeros, right? Poles, let's say. So if this is the case, which has like this is minus 45 degree and minus 90 degree. As I told you, we are only interested in the feedback, because open loop system is not the stable one. Open loop systems are not the stable one. So we are going to keep everything in feedback, but that feedback will be always negative. Just remember one thing, whenever there is a positive feedback, there are oscillations, or it will reach your VCC and ground, the supply, power supplies, right? So output of this one, in this case it's same as that one with some dynamics of this op-amp transfer function. In this case the output is plus V supply and minus V supply. So this is plus V and minus V supply, because this is an oscillator. I don't know whether have you studied this Smith trigger. So but in this kind of circuit is known as Smith trigger, and it's always going to give you the oscillations. It's positive feedback. You can see the positive feedback, right? This case it's negative feedback. We are interested. Yeah, so then you have to understand Smith trigger. One other day we will have Smith trigger. If you want to, they are different. Outputs are different. Both the outputs are. So plus V supply. Let's call this one plus and minus 10 volt. Plus 10 and minus 10. This case, this is 1 milli and minus 1 milli. So output will be 1 milli and minus 1 milli. Right. So both are different. We are touching directly the supply voltage. We don't want that. In some cases we don't want it, but in some cases we need it. Like we need it for PLL circuit or the clock generation. Right. All the digital system needs oscillator. Right. Okay. So if you are interested in negative feedback, means if I am applying here plus, output should be minus. if I am applying at this terminal some plus value, output should be minus. Means you can understand this. Let's assume that I am having a remote control for the AC and I am setting temperature at 27 degree. It's a reference. So the mechanism which is inside the AC, it tries to reach 27 degree, but when it reach 27, maybe it will go up. In the next loop it will try to make it down, and maybe after some times you will get exact 27 degree. So if it is going down, then it's negative feedback, which was happening here. So this is going plus, so this is going down. If this is going in next time, when it's going down, this is going up. If this is going up, then this is going down, and it tries to reach where they need to reach, right? This is called, this is stable system. And such system we need to develop. Whenever you are doing this, you can see that this side is plus and that side is minus. In terms of mathematics, I can see that if the input is sine wave, output is 180 degree phase shifted sine wave, right? If this sine and this sine has 180 degree phase shift, right? So if input is this kind of sine wave, output is this kind of sine wave, means I need to make the datum line as 180 degree. So at the output I am interested to measure the stability not at 0 degree, but I am going to measure at minus 180 degree, and I need to check how much far away my phase is from 180 degree. Means I need to subtract, or whatever the phase is coming, I need to make it with 180 degree. That is going to give me the phase margin. That's the equation of phase margin, and that is on the basis of one fact, that we are going to operate whatever the system you are making in negative feedback. So in this case, at GBW you are going to see 90 degree phase margin. Do you agree with me? Okay. One more thing, phase margin is only measured at unity gain bandwidth. It's only measured at, because that is the point which is going to tell me my V out and V in are equal, right? So that is what I need to check. Otherwise my gain is decreasing. Afterwards it's not useful. After the bandwidth, the system is not useful, right? So phase margin has to be measured at UGBW. For single pole system you are going to see plus 90 degree. Do you agree with me? For double pole, when poles are more, what do you think? What will happen to your phase margin? 0 degree. So 0 degree is good or bad? Good or bad? Because look at the design key points. We have to have the phase margin greater than 45 degree. It's only possible when there are, okay, where is that? If there is only one pole inside unity gain bandwidth, right? If there are 3 poles, even it's worse. As you are going below 45 degree, it's the worst thing. Or number of oscillations you are going to see. Are you following this? Okay. So this is what I meant. If it is single pole system with minus 20 dB per decade, at UGBW you are going to see 90 degree. If there are 2 poles, you are going to see 0 degree. Yeah? All good or no? If there are 2 poles, this first guy is going to give you 0 degree, and at infinity minus 90 degree. At center frequency it's minus 45 degree, the pole number 1. If there is a system which looks like this one, so this is for pole number 1. Pole number 2 is also contributing same thing, but it effect starts when there is a pole 2. So near to pole 1 line, you are going to have 0 to minus 45 and then minus 90 degree by pole number 1. And afterwards, another pole will start from minus 90 degree and it will go till minus 180 degree and minus 135 degree at exactly the center frequency, because both will be added, right? So that's how you are going to see some bad results. And when you are going to do it in body of H, yeah, you can keep it for my name. Right? Yeah.
like concavity कैसे देखी 45 पे
This one
downward है
I made it in the software where I was not able to make the sharp line. That was the problem. Otherwise, it will be like this. Right? You can see that in the Bode plot in MATLAB. That will be the correct result. I'm just drawing right now the approximatory results. This is approximation. And I'm teaching you like the intuitive way that your system will be stable or unstable. So right now, can you tell me the system is stable or unstable? Unstable, right? Because phase margin is 0 degree, right? If there are 3 poles inside, the system is again unstable. But if there is one pole inside, and let's assume that the pole number 2 is here somewhere, little bit above UGBW, then it will start contributing afterwards and your phase margin is better. Maybe we'll talk about this maybe tomorrow, not today, but this was just to start explaining you that how the system becomes stable and unstable. Are you following this using phase? Hmm? Others are waiting, but phase margin, okay, I'll talk about this tomorrow because others are waiting outside. There is, because of National Science Day,